Afternoon, grade 12. So, as promised, we have to cover organic molecules or organic chemistry as our first topic very early, because if siyaqaphela pha kwi-ATP, that topic is supposed to be about 4 weeks, and it's going to give us like it's going to take a lot of time for us to cover that topic. So it is going to be advantageous for us to start very early. Hence, I'm going to provide introduction this early. Part of introduction is going to be what I've already covered, the bit that I've covered last year, which is the terminology that I gave you. So basically, lesson objective is going to be the basic terminology. And then I might add examples here and there, because that terminology requires us for illustrations. Anyhow, we have to remember Lewis structures basically from grade 10 and 11 in order for us to be able to draw the structures of organic molecules. So basically, as we discussed last year, sazibuza, but what are organic molecules? Organic molecules, and we said those are compounds that have, for obvious reasons, carbon atoms, and we add sathi bana they are typically bonded to other, I'm just going to say C atoms for carbon atom, and hydrogen, and H atoms. Now you immediately notice that not all organic compounds have carbon atoms and hydrogens only. When I give you examples, uzayibona phala, but basically that's why we don't consider CO2 as organic compound, because it doesn't behave the same, it doesn't have a trend of it behave as other organic molecules, or rather it doesn't have physical and chemical properties zazo, which is also H2O and also metal carbonates nezinye bantu zininzi created as molecules zinazo carbon atoms, but basically typically organic compounds, we're having a carbon atom here that is typically bonded to other carbon atoms, but also there's a hydrogen atom, and there might be kwesa structure oxygen phaya kwesa structure, there might be halogen, which is fluorine, what is it, iodine, bromine, or fluorine. There might be these atoms there, but the carbon has to be present in these molecules, and also most of the time, almost 100% of the time, hydrogen is also present. But we will see as it's ngazo, because it also has something to do with chemical and physical properties. So we'll see how we have these exceptions. So now let's get into a definition to qala, which I think I gave you last year. That is the most important definition here is the homologous series. Homologous series. So homologous series is the first guide yethu. Let me use another marker here. Homologous series is a group of organic compounds that have the same functional group and general formula. Okay, let's just highlight those two terms which just came in, which is a functional group and also which is a general formula. In other words, if organic compounds are said to belong in the same functional group, they must have the same functional group and the same general formula. So these two have to be covered. However, each general formula will cover it a little bit later on. So I will just be adding a terminology, people, and make examples as I said. So now we ask ourselves, what is each functional group? Functional group. A functional group, it is an atom or group of atoms. I might be moving words around, but it's still going to be the same exam guideline. Atom, group of atoms, or a type of bond that determines the physical and chemical properties of an organic molecule or compound. Let's just say compound. Compound. So atom. So for our purposes, these atoms, it might be the halogens, which is let me just say Eg per. So Eg of functional groups it might be atom. Atom. So it might be halogens. As I said, it might be a bromine. It might be an iodine. It might be a chlorine. It might be a fluorine. Yeah? So these are the halogens, as this says. Or it can even be oxygen. Yes, oxygen bonded to OH. OH from grade 10. OH. So OH now by functional groups, we'll talk about it later on. But basically, atom is the halogen for our purposes. Halogen, yeah. Or a group of atoms, it might be talking about a hydroxyl. Hydroxyl group, but not limited to as groups. I don't want to complicate things. Just stop there. So it is an atom, and also a type of bond. Very important, a type of bond, which is basically what we're going to cover today. So it might be a single bond, single bond, recognized by one single line which represents 2 atoms, if you remember correctly. And then we have two lines which represents a bond order, sasisho last year, which represent a double bond. And also we may have 3. What is it? Triple bond. Yeah. So this is the bond order. It's the bond order. Okay. Let's just say type of bond. So this one will be representing group of atoms. Group of atoms. This one will be representing an atom. An atom. Yes. So back to this statement say to a functional group, it is an atom or a group of atoms or a type of bond that's going to determine the physical and the chemical properties of an organic molecule. So determine what are these physical, chemical properties. We're talking about the boiling point, people. We're talking about a vapor pressure. We're talking about a melting point. We'll add the melting point this year. Yeah. So we talk about those 3 properties. Not that there aren't others. Density. We are not going to focus on such things, but those 3 are very important. So what we have here, we have the organic molecules, ne? And the organic molecules, snake group zazo. Class group zazo, we call them homologous series. Sizibona njani different groups? Sizibona ngantoni nge-functional group and also ngantoni nge-general formula. They will have the same functional group and the same general formula. What is a functional group? A functional group is an atom, a group of atoms or a type of bond that will determine the physical and chemical properties. In other words, people, if organic molecules belong in the same group, they will have the similar, not the same, but similar physical and chemical properties. So let's place the organic molecules there too that we are going to focus, and I will re-explain what I just said. So I think I have saved, but I don't know now. Let's go to pictures, choose image. Yeah, I'm looking for this one. Let's place it somewhere here. So now I have examples here. So what name of group ne? Let me edit here. Ditikuwe upper glow green, le part le green. I could have written upper homologous series. So these are homologous series. Yeah? So examples of my homologous series upper, there are 3 that we did last year. I remember specifically because we didn't teach along, which are alkanes. Yes, alkanes. Alkenes, ibezi alkynes, ibezi haloalkanes or alkyl halides. The name itself can suggest apa halo suka ku halogen. Alkanes, so alkane le enandoni alkane ene halogen, yeah? Masiqale. First things first, these are not the only homologous series as thousands, ne? There are also alcohols, there are also aldehydes, there are also ketones, esters, and carboxylic acids. But let's wait for those. It's 2A, this is colors, this is basics. Then we will see where we go from here. So I'm going to open a table. I prefer to open a table. I don't have to open a table, but I want to restart the table. Hey, let me just say homologous series. Homologous series. And then I will write eqaleni. I will write a functional group. If ever ulibelba indoni homologous series, the functional group, you can pause and you go back, give it to. So you can just go back and check the level needed. But I will repeat it for our purposes. And then now, we have a way of naming inantsika zethu homologous series zethu because sizaba ne prefix semazi mase prefix yala la part yokuqala in a name prefix, and then we will have a suffix. Yeah, I wanted to get the prefix and the suffix. Yeah, there. Anyhow, let me go back to the table. I could have done this in one table. It's going to be complicated. Or I think, let me just check. Why don't I just write that here? Let me just write prefix, suffix. Yeah, it's easy. Okay. 30 long route. Let me just take the short route. So we have our homologous series here. I said let's just write homologous series. So we have homologous series that are 4 for the time being. I'm not saying there are only 4 homologous series. Many homologous series, some of which we won't even cover. I think if you will remember what grade 10 sugars, we spoke about sugars. Lipids are also homologous series. Nucleic acids, DNA and RNA are also homologous series, but we're not there yet. Let's just start here. So basically, what happens is when we look at these, there's also that type of bond, which I almost forgot. So if ever you look at alkanes, typically a functional group, this is a functional group, people. You don't put hydrogens there, you only. Then if you look at that, alkanes always have a single bond between the carbon atoms. So that is their functional group. The name of the functional group, yeah, I should have written here name of functional group. I don't have time to erase. Functional group. The name of the functional group is going to be a single bond. Why? Because if you remember, we said a functional group, it is a what? It is an atom, a group of atoms, or a what? A type of bond. So a type of bond, they have names because this one is a single bond, this one is a double bond, this one is a triple bond. So now if we go from there, we can look opposite, a single bond, yeah, between C atoms. We don't have to say that, but it's a single bond between C atoms. And when we name them, e suffix, prefix of it up. E suffix always supposed to end with the letters A and E, which is ain. If you remember, when we name prefixes azo, we start from methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, corresponding to the number of carbons. I will write that eqaleni, can't be a space up. Anyhow, size we alkene. Alkenes would end with the suffix E, N, E. And then, now, what is the name of their functional group? People, that type of bond between carbon atoms is double bond. So, it's going to be called, double bond. And then, now we get to E, alkyne. I think you will see a fellowship pattern if you have paused the video. So they will end with YNE. Suka phala YNE ne? la ANE usuka apa, la ANE usuka apa, ne? Why? Yeah. And the name of the functional group, always between two carbons payana, we have E triple bond. So triple bond here, triple bond. And then now we have the haloalkanes. People, zona, because alkanely, it just happens to have a what? To have a halogen, like X, meaning somewhere in the chain there is a halogen. Ne? I will demonstrate this again. So somewhere in the chain there's a halogen. So because the alkane you just A and E, but now we will be guided by naming rules as to what's kalang. So this one, it must have a single bond now. But if functional group payana, it's going to be single bonds payana, single bonds zikhona ne, but also ukondoni paya halogen. So that halogen, we're just going to name it as the functional group there, because it's the most recognizable thing there. But apa kuki atom a halogen, but the type of bond if you get there is the single bond. Now let's go back. Swele back paku homologous series. Ubepale homologous series payana. Ubepale loni? Homologous series, a group of organic compounds that have the same functional group and general formula. I left that part out because I was going to come back here. So now we are saying general formula. Let's write it there, general. Basically, each general formula you don't have to define it, but it's for writing the molecular formula, people. So basically, each general formula alkanes with CnH2n plus 2. Each general formula of alkenes, CnH2n. General formula of alkynes, CnH2n minus 2. Then the general formula 2 minus 2. The general formula for haloalkanes, CnH2n plus 1 X. That X will stand for whatever halogen is present in that molecule. So let's make examples. Then depending on the repeater, homologous series and also a functional group. Yeah, it's going to help us. So when we name molecules, we use a prefix. So if ever organic molecule has one carbon, we are kumbula. I'm talking about prefix here. If ever one carbon, we take 10. One carbon, whatever molecule, we belong to a group, a functional group, a homologous series. If ever there's one carbon there, your prefix for the main continuous chain or for the main chain. If there's one carbon, ula meth. And if you remember, meth, bingugula ka methane umzekelo. So u2 wethu earth kanye ngathi eth, I don't know. Then O3 again, 3 umele prop. Then 4 but, 5 for pend, 6 for hex, 7 for hept. You'll notice now it starts to follow the naming mechanisms of your polygons, maths. 8 will be oct, 9 will be non, 10 will be oct. It will continue, people, to hundreds, thousands of carbon atoms, but Tina, we're interested in the first 10 carbons. So let's do an example and see if we can recognize the structures. So if you remember, I had said where we will be using upper. Let's just start with alkanes. Alkane, so that we are all familiar. Alkanes. We remember that alkanes follows the general formula CN H2N plus 2. That's the general formula. And the alkanes, they have what? They have single bonds between carbon atoms. Yeah. So that's what we expect. So if I give you atom, you should be able to recognize it based on the, if I give you molecule upper, you should be able to recognize it based on the number of carbons present in the molecules. So for example, we will say 1, 2, 3. Now the atom, the molecule has 3 carbons. Now if you remember, when we draw the Cooper structure, each line represents 2 atoms. Yeah? And a carbon, it must be, it must have an octet structure. In other words, it must follow the octet rule. It must always have 8 electrons or 8 valence electrons. 8 valence electrons. So funeka ibe nemiqa. Noba imenjani la miqa, but la miqa ibe ngaphi? Ibe 4 la miqa. Now, because apha intoni lena yi-alkane, it means le miqa ayikwazi uhlala kwindawo yi-1, because the minute ihlele kwindawo yi-1 izawuba yi-double bond. The minute i-3 ihlele kwindawo yi-1 izawuba yintoni? Izawuba yi-triple bond. But siyidefine ngantoni i-alkane? I-alkane ine-single bonds between carbon atoms. Ngamanye amagama ithetha ukuthini loo nto? Now le miqa funeka ibe kwi-peripherals, emacaleni. Here they are. Yes. So now we ask ourselves, what do we put there? Now there's a word that I left out, but let me just write it. Let me look. Let me write it here, because it was a mistake that I have left it out. It's called hydro. Let me look for that document. Okay, it keeps erasing. Let me just write it here. Sonke is ne? They are hydrocarbons. Hydrocarbons. I feel like to use another color. They are hydrocarbons. Now we ask indoni hydrocarbon. So let's just write it here. Write it here by indoni hydrocarbon. What is a hydrocarbon? Hydrocarbon are compounds that consist of even a hydrocarbon. So a hydrogen. So hydrogen and carbon atoms only, by the way. And only, if you leave that only, you get 1 mark, because you only, because you leave ambiguity, because it is hydrogen and carbon. What if you in fluorine? That means fluorine is about haloalkane. So basically, alkanes, alkynes, they always only consist of carbon atoms and hydrogen atoms. We come back here now, the alkane. What do we expect to put in those peripherals? Hydrogens, because the alkane indoni hydrocarbon. So now funeka ibe hydrocarbon in hydrogens and carbon atoms only. Nanso ke ne. Now let's go back to our naming scheme. Sikhumbule, how many carbons are here? Let's just start by counting how many carbons are there. So carbons is present here. 1, 2, 3. There are 3 carbons present. Ithetha ukuthini lonto? In our prefix funeka siyochuza bani pha? U3. So choose apha U3. Ne? Because we've chosen 3, it means now the name yethu must start with prop, people. So ngu-prop lo. Prop. Now sisibuze. Prop ntoni? What is going to be our suffix? Sawugqibela ngantoni? We go and check. Remember the suffix of the alkanes. It's what? It's ANE. So what is the name of this molecule? Propane. Yeah? Propane. We can do, but I will move a little bit quicker now. A second example. Let me just use a pink marker. So here's another one. C. Remembering that an alkane is a what? It has single bonds between the carbon atoms. So I cannot put extra bonds here. Yeah? Because the minute I put extra bonds between carbon atoms, I make it now have double bonds. And it does not qualify to be an alkane now. It does not qualify to be an alkane. Therefore, what must I do? I must put hydrogens where? Emacaleni. 1, 2, 3. Why ngizofaka 3 apha? Because le carbon lena, it must have a stable octet structure. In other words, it must have imigca emingaphi? 1, 2, ibond ezingaphi? Let me use proper names. 1, 2, 2, 3, 4 around it. So ibonds ezilapha ziyi-4 around that carbon. In other words, it has a stable octet structure because 4 bonds mean 8 are equal to 8 electrons. So lena yona 1, 2. Why yona? Because 1, 2, 3, 4 bonds around it. Same for lena. 1, 2, 3, 4 again. Yeah. So how are you going to name it? Again, we will recognize that there are single bonds and also there are how many carbon atoms there. If ever your molecule is symmetrical kanji, you do not have to start from the left. You can even start from the right to 1, 2, 3, 4, 5. How many carbons are there? 5. 5. Which prefix do we use? Pent. Pent wethu. That means I'll start with pent. Belong to which homologous series? Alkane. How do we know that? Because they are single bonds between carbon atoms. So that is going to be what? Pentane. Ne? Now, let's just use another example now. I'm passing there. So basically, if I can repeat, basically for alkanes, people, sinandoni, sine methane, sine ethane, so sabane methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, octane. People been phazamile bakani nibona. Yeah, by decane, povan kolap. Decane, people, ne? Decane, December, decane. So, hopefully, December, 12. Decane. Anyhow, That is the basics of organic molecules. Basically, how do we name them? We name them according to which homologous series do they belong to. Our homologous series is defined by a group of organic molecules that have the same functional group and general formula. For the alkanes, functional group yazo is single bond, people. Is single bond between carbon atoms. It's going to be the single bonds between carbon atoms. And then now general formula. Now I'm coming to the general formula. I almost missed it. The general formula, let me stop there. So each general formula is 10. Cn, there it is written, Cn H2n plus 2. If you remember, but I will re-explain. So basically, that's it is Cn H2n plus 2. We need to ask ourselves, if ever we want the molecular formula, how would we get it? We will use a general formula. But before that, if Ben's class, I would ask you, do you remember what a molecular formula is? Or what does it represent? If you remember, if I say H2O, that is a molecular formula. And this molecular formula, it tells me the number and names of each atom present in the molecule. So which atoms are present in the molecule is hydrogen and oxygen. How many hydrogens? 2. Or how many oxygens? 1. Yeah. So it's something like that. So now we ask ourselves, how do we use this general formula to obtain the molecular formula? The N there stands for the what? The number of carbons present in the molecule. So if I want to write down the molecular formula of propane, what am I going to do? I will say C. And then write how many carbon atoms are there? 3. H2 in place of N. Remember, N still stands for the number of carbon atoms present in the molecule. So it's going to be 3. And then I will say plus 2. So basically, in molecular formula, iphela ingu C3H, notice 2 times 3 paya. So is about 6. 6 plus 2 being 8. So this ends up being the molecular formula of propane. So let's go back. So check here. But how many carbons are there? It's 1, 2, 3. How many hydrogens are there? It's 1, 2, 3, 4, 5, 6, 7, 8. So yeah, measure, people. So let me go back. Sine formula pa Z2, people. Z3. We have the general formula. Each general formula is applied for all the homologous of all the compounds in the same homologous series. Or all the compounds that have the same functional group, which is a single bond for alkanes. Yeah, general formula. And then we have a second formula here, which I gave you initially. And I explained the formula. This is what we call the what? A structural formula. So this one we call a structural formula. And then structural formula, structural formula shows us which atoms are bonded to which. If you look at this structure, I tell myself, carbon 3 is bonded to 3 hydrogens. Carbon 2 is bonded to 2 hydrogens. Carbon 1 is bonded to 3 hydrogens atoms. So I'm shown there in the structure as to how the atoms are bonded and what atoms are bonded to which. So which atoms are bonded to which, and then Molecular formula, it's showing me the number of atoms present in the molecule, the exact number. This is a molecular formula. So basically, I can give you a molecular formula. When you need a structural formula, when you need a structural formula, you need a molecular formula. When you need a name people based on a guidance. I am going to start with this part when I for the next lesson, the type of formula that we are given and our naming rules. I'm just introducing you up. And then for this one, again, people will just say C. Remember N loane. So in place of N, sautina 5. Sitting C H. Remember H we see N muswa H2N plus 2. So in place of now, so the 2 times 1, 2 times 5 plus 2. So 2 times 5 is 10. 10 plus 2 is 12. So 12. So it pentain in molecular formula C5H12. Its structural formula sayo looks like this, where you have 5 carbons and the terminal carbons have 3 carbons. Terminal is the same people in the peripherals. They have 3 carbons, and then we have 3 other carbons is this pakatini, which are bonded to 2 carbons each. Yeah? I'm going to stop the lesson up, say peli period. So what I'm going to do, I will give you homework of what we have done. I'll type a group in when you can start submitting. Anyhow, I'm stopping here. Remember to go back to the lesson. When it takes us slow, don't want to move very fast. Anyhow, tomorrow we will talk about the other homologous series, which is the alkenes and alkynes and haloalkanes or alkyl halides. Let me stop here.